Check out what I just got in the mail. Package from China. U-Power. So, I thought I'd change it up with my inverters a little bit and give this one a test. Oh boy, what do we got in here? I think that gives you a bit of a clue. Alright, I'm going to just pause this for a second and pull this out. Alright, first impressions. It feels almost too light to be a low frequency inverter. It's, well, yeah, it's definitely too light for 3000 watt. But all the weight's in the front, so I can tell that there is a transformer in here. But it's very light. The case is made of something really thin. I don't know. I doubt it's stainless steel. No, it's already resting a little bit. Or maybe that's part of the, when they cut it out, I don't know. Either way, it's fairly light. It's got a high speed fan on the top here. Ooh, I just dented that. Look at that. Alright, I pulled it back up. And it looks like they put some covers, some tape over top. That's hilarious. Let's see. You got your fuses in, or output fuses, sorry. You have power save mode off. You got two receptacles, and you got your terminal block. Backside, just got an exhaust with some ribbon cable in the way that's just kind of moving around in there. Some beefy lugs. Got the bottom side. This is the inverter that I got. 24 volt, 110, 140, or 120, 140, 60 hertz. Alright. Very cheap inverter. Well, it was 300 bucks Canadian, so that's about, what is that, 240 American, something like that. And we're going to try this out. We're going to take this apart, put it through the ringer, and then yeah, this is probably going to be a part 1 part 2 video. It'll probably be too long if it's all in one video. So yeah, hope you guys enjoyed the video. Just changing it up with a power jack El Cheapo inverter. This is actually, these are cheaper for their wattage range. If it can push that, it's a good deal. If it can push half of that, it's okay, not really a good deal. If it can push less than half that, it's a terrible deal. So we'll find out, because there's lots of competition in this price range. Just feels very flimsy. Oh, look at that. You can see the transformer through there. It does have a round transformer. Okay, let's get her apart. This is a power jack 3000, and we are running a 1500 watt load and a 300 watt load, so we're about 1800 watts. It is not pushing 1800 watts though, because your voltage is sagged. We're sagged to a square wave. Fan just turned on, so I want to wow, that is quite the fan. Holy smokes, I'm gonna unplug all this stuff now because I don't want to. Actually, I'll show you. This is with just the light on. That is sine wave without a load, which is okay. This is on the 240 side because this is a split phase inverter. Wow, that is a powerful, loud fan. I'll show you each phase. There's that phase. The one filter or capacitor, whatever this is, was broken, so I put a zip tie on it. I'm gonna have to replace that. This whole board is loose. It's not fastened anywhere. Terrible design. Build quality is not good, but I want to see if it can run anything. It says it's 3000 watts. See, this side is actually pretty clean when there's no load. Same with the other side. The second you put a load on it, it goes kind of to crap. This is both sides of the transformer, so this is 240, line 1 and line 2 hooked up. But I believe if I put a different, get that just right. Oh, yeah, that made a spark. I don't want to touch that. I don't want to. All right, now I got another. I believe these are little capacitors because it reads. This is what it reads on the capacitor. It's a little filter, I believe, 400 volt, certain amount of joules. I'm not sure what that is. I gotta look at that part number. But I'm hoping that this slightly bigger one doesn't make a whole lot of difference. I'm pretty sure it actually has the same numbers on it, so it might be the same thing, just in a larger package as this one. So I'll once I solder it and I can actually bend it back, I'll show you guys the part number in that. But even with this attached, I tried it with just alligator clips. I still get a really dirty sine wave on the one neutral to hot, and then this neutral to hot is very clean until I put a load on it, and I will show you what that looks like shortly. Right, so now it's all soldered up. I'll show you the numbers on this one on this side that I replaced it with. It's very hard to see, but it's very close. I believe they're the same numbers. I gotta look at this video after. But it runs, it works, it is cleaner, but not perfect. So it's on now. I put the case back on it, and I'm gonna put a load on it for a bit. What I got for batteries is just a lawnmower battery, a deep cycle battery, and I have it hooked up to my I guess universal power supply. This goes up to 400 watts, and I have it set to 15 amps, so this will be supplying 15 amps at 28 volts to the system. And I'm going to just put a load on it until these batteries can no longer support the load, even with the charge, enough to get the fan to come on. Even though it's cold outside, you can probably see my breath. And yeah, give it a little stress test. I will say I really like the modular design on the replaceable MOSFET boards. Like, you just take 1, 2, 3, 4, 5, 5, 6, 7 screws, replace all those MOSFETs. That is super nice, super convenient. That is a really good idea. Yeah, so for this reason, I like this inverter. I do not like the fact that, look, all they have is these standoffs. They're not screwed to anything. This is not fastened to anything here. I put this duct tape on because it was hitting here. I'm going to be gluing those standoffs to the heatsink. But yeah, anyways, let's get to testing. Upon further inspection, I noticed that these two filters actually are in line with each other. I didn't even look at the board. And only 2 wires are coming off of the transformer going to this board, which are these 2 here, which get filtered. And the other wire, so these 2 are in parallel for some reason, I'm not sure why. This one's single. These go to the board in parallel. This goes to the board as well. And then the last wire, this one here, goes right to this fuse. Doesn't go to the board, doesn't get filtered or anything. And I'm pretty sure that's why it's such a dirty sine wave on that one leg, which is very interesting. I'm going to try and put one of these on it, perhaps. I'm going to figure out what goes where. But I believe if I take this and put one of those filters from here to possibly the neutral, I might have my cleaner sine wave, but we'll see. Anyways, so until next time. Alright, so I've added some epoxy to these mounts here. So now, once it dries, at least it won't go anywhere. I have our wrap tie on there just for now. I'm going to add the filter to the other side of this transformer later. But now I'm going to just run this thing until the batteries either go dead or it shuts off from overheating. And I use this heat gun and this light. This light will be 300 watts. This heat gun, I believe, is 750. And we're going to see how that goes. It's interesting. That meter I had must not have been correct, because this is on 750 and that's 300, and we're not having any issues at all. Now I'm going to try 1500. Now we're on 1500. and 300. And we're just at alarm. We're not having any problems. So I think that meter must not have been working correctly. It does get brighter. I'll show you guys over here. So that's 1500. That's off. Then that is 750. So it holds its voltage at around 1000 watts, but anything over that, it definitely droops in voltage. So I think it's pretty much the transformer is the weak point on this thing. Anyways, we're gonna let this run for a while, see what happens. All right, so we're gonna try this Mastercraft compressor here. This thing takes a ton of power. It makes the lights dim in my garage when they turn on and everything. This thing takes a ton of power, and I want to see if that power jack, if it can actually run this thing. I will be very, very surprised, even if it has, you know, drained the air. Give it the best possible chance, because it does not have a lot of power for running bulk loads. Okay, we're going to plug it into, this one is the regulated output, this one is not regulated. So let's see if it runs it. Nope, it has some protections though, that's pretty cool. Alright, let's try the non-regulated one. It definitely has a much more zappy sound on the non-regulated. Okay, so it really does not want to start, eh? Don't really like how it just keeps trying to start it, but well, it tries anyways. So 3000 watts, no, cross that out right out. It's about 1500 watts continuous on 240, and about, I'd say, I don't know, 800 watts per leg. 800 watts, 800 watts, both together, you're gonna get 1500 to maybe pushing it 2000. I doubt it though. I don't think this will output 2000. But I do have only 2 small batteries. They are constantly being charged with a 15 amp charger. But yes, would I recommend this? This was $300 Canadian. And yes, I paid that. I would not recommend this for $300. This is absolutely terrible for $300. For $300, you could get yourself a reliable inverter, and this is not the best inverter you can buy, but it's decent. It's high. It's a high frequency inverter. This one's 48 volts. I have this battery I built for it. This is a high frequency inverter, and it puts out way more power than that one does. This one here, I bought broken a while back, and I repaired. So this one puts out about 2000 watts now. I don't know, I can't remember if I used the proper MOSFETs or if I put lesser quality ones in or not, but usually these come and they'll run at least, if it's 3000 watts, they'll at least do 2500, and some of the good ones will do the full 3000 watts no problem. And these are about the same price. You can find these for around 300 bucks, maybe 350. So I would definitely recommend that over this inverter. This inverter, I don't know, if this was like 200 bucks or less, it might be a decent buy. Like, it does starts that thing, the electric impact gun. I still have some other tests I want to do. One thing I really want to do is I want to take this transformer. I can go from 120 to 240, or from 240 to 120. So I want to go from the 240 of this down to 120 and go into here and see if this will run more, because this is taking both taps off the transformer in here and making it so I can pull out of one plug instead of having half at this plug, half at this plug. Another thing I noticed was you can pull more power if you're pulling some out of this plug and this plug, it actually complains less. If you pull just out of one plug, it's not very happy. You can't pull as much. Yeah, I didn't blow any fuses yet, which is surprising because I was just overloading it. I don't know if it's supposed to have that little drop in the middle or what, but yeah. Anyways, so far it's not the worst inverter in the world, that's for sure. Like, it's taken a lot of abuse and it hasn't died yet. So we're gonna put this into circulation. I'm gonna build a battery for this. Actually, I might put this in my portable LiPo box. We'll see. Look at this. It's got some sort of, wonder what's under here. It's got some sort of a covering here. It's got a website. It's probably their old website or something. I don't know. That's hilarious. They just stuck a little piece of something on there. I just noticed that. Anyways, thanks for watching, guys. Hope you guys enjoyed the video. We'll have to do some long-term testing on this thing. See if it can at least last the sands of time. We'll see. Anyways, see you guys later.